Hello everyone, nice to have you back here on this webinar, which is going to deal about the power of VNIR for hyperspectral imaging. VNIR stands for Visible Near Infrared. First, about myself. You know me now. I've been dealing with quite many of those webinars. I'm Mathieu Marmion. I'm working as a lead application specialist at Specim, working now for more than 20 years, and I will be really happy to be your host here. About the agenda. First, I will give you a general overview about Specim, what is hyperspectral imaging, also emphasizing some of the key applications, what needs to be taken into account to integrate successfully hyperspectral imaging into your facilities or into your products. And finally, we will be happy to answer your question. First, about Specim. Specim has been founded in 1995, and since that time we have been able to deliver more than 10,000 spectrographs and cameras. Nowadays we are located all around the world with facilities in the United States, Germany, Spain, Finland and China. Our headquarters is still in Oulu, where you see here on the slide. We have about 90 employees, and since 2020 we're actually part of Konica Minolta. Let's go into hyperspectral imaging. I will not go too deeply into the topics because we spoke about it in many webinars in the past, but still, just to give a background. Hyperspectral imaging is a combination of spatial and spectral information. Spectral information to make qualitative but also quantitative data analysis to extract some information about what you want to look at, and then the spatial information to see the distribution of those properties of what you want to look at. So hyperspectral imaging is a combination of both. This webinar is actually part of a series of 5 webinars. The first one is here about VNIR. The VNIR spectrum is between 400 and 1000 nanometers, as you can see here. It means that it takes into account the visible light, but it goes a little bit over like the near infrared. What is the VNIR hyperspectral imaging? Typically a setup looks like this. You have a camera, which is a line scan device, and each pixel of the line could gather some independent spectral information, as you can see here. Then you have the illumination, and basically the camera measures for each pixel what is reflected compared to what is incoming. And the ultimate goal is what you see is to actually from raw data to extract information, and in that case to make some classification, for instance to separate walnuts from their shell. On this slide, the one which is now, you have actually the possibility to see a real image, hyperspectral image, within the spectral range VNIR between 400 and 1000 nanometers. This one was acquired with an FX10. You can see for each of the pixels it's possible to extract a spectra. Here you have the average one over the yellow and over the orange areas. You can see the average spectrum, and then from that you can deduce, you can see differences. Just to highlight here, for instance, for the pistachios, you can see the spectrum in yellow, and you can see the oil in the fruit, which is at about 930 nanometers, whereas you don't have it, for instance, within the shell. All right. After having given you like an introduction about hyperspectral imaging, I will be going through some of the key applications. Now if we speak about the application which are actually related to the spectral range VNIR between 400 and 1000 nanometers. Here you have an overview of the different applications where the VNIR camera could be used. This slide, it just could give you an overview of what can be used, but there can be many others. So as you can see, there is one of the corner in one of the square, it's written new applications that could be used as well. And I said here, it speaks about agriculture and vegetation mapping, food, environmental monitoring, art, thin film thickness, color control, phenotyping. Anyway, this is just an example of application. This is not everything. In the first application I'm going to speak now, it's about color control and display in general, or even more. So here, for example, you can see my previous mobile phone, which was a good mobile phone, by the way, but that's another story, where we actually imaged a test image like this, and we measured it with the IQ and also with the FX10. Then, once this image is taken, it's possible to pick up some point and then to convert those related spectra into color coordinate, and it's possible like this to estimate what is the gamut of the mobile phone. This is very suitable for like display inspection, but also for LED inspection, color inspection in general. The next application is more related to food analysis, and here we would like to thank the University of Wageningen, who has developed a hyperspectral imaging platform, including our cameras in there. There is an FX10, which measures spectra again between 400 and 1000 nanometers to make food, especially fruit inspection, for example, to quantify Brix index, also the moisture as well as the maturity. But notice that it's possible to combine camera together, not to use only the FX10, but also the related one for the VNIR, which is between 900 and 1700 nanometers. So to have a combination of both to get even more information. In the next application as well, it is a feasibility study that I have made myself. So basically, I went to the shop and I bought 3 tomatoes, 3 plums, and I measured them over the time, over 3 weeks, like this on our lab scanner with the FX10. So here you can recognize the system. And then I was measuring like this over 3 weeks, and I made a model to measure, to estimate the maturity of the fruit over a certain time. And here you can obtain this kind of regression map, as you can see on this slide. The interesting part is that you can see that over the time, the spectra is actually changing. You can see the early stage on the left-hand side, which is in light blue, related spectra. Then there is also the middle stage, and then there is also the late stage. And you can see that the spectra is actually changing over the time, you know, especially in the NIR, where the firmness, where the water content is actually changing. The next application is more related to remote sensing, about environmental monitoring, because indeed hyperspectral cameras, they can be used in airborne platform, meaning it could be in UAVs, in airplane, and also in helicopters. On the right hand side, this is a slide provided by Spectir, who is our partner in the United States. They were using our VNIR camera to detect the presence of oil leakage and spillage over the sea. On the left-hand side, it was over a lake, more to map the chlorophyll content, but also the total solid. The good thing with the VNIR spectral range is that it penetrates into the water, so then it's possible to obtain such map. The next application could be also related to remote sensing, like precision farming, to fly over fields, but it could also be used inside laboratory or greenhouses. So here you can recognize the FX10, which is here to inspect tomatoes plant and how they are growing, how they are stressed, if they have any lack of nutrient or things like this. And on the right hand side, it was actually ourselves. We measured here the tomatoes plants that we let die over the time without wetting it. So it was at 2 different stages, and by choosing relevant bands and making the ratio, it's possible to compute like this NDVI, highlighting like these different properties of the plant. The next application is more industrial. It was about film thickness, very thin one, and it is something which is actually very important to control the thickness, because if a film is too thin, it means that it is too fragile. If it is too thick, it means that it doesn't have the same stretching possibilities. So here we ask some of our suppliers of thin film to send us some roll, and we made some inspection. Just to give you a background about this application, typically the thin film thickness, or the film thickness, is monitored with a point spectrometer, which is moving from the left to the right when you have a film which is rolling like this. So basically you have an inspection pattern which is making a zigzag like this. You can recognize that actually the inspection is not very global, but with a hyperspectral camera used in a specular fashion, it's possible to inspect not only point but line every time, so it means that the inspection is more global and more complete. And then it's possible to obtain such a heat map as you can see here at the middle. When we created it, by the way, we noticed 2 stripes, and we were first thinking there was an issue in our measurement setup. Then we looked at the thin film, and we actually recognized those 2 stripes as well. which was then not really a default, but something that our camera could detect. Then we will go to something which is more like artistic, with the use of hyperspectral imaging for art and cultural heritage inspection. Here you can see our IQ camera, which is used for painting inspection. The good thing with the VNIR spectral range is that you can really detect or you can inspect different types of pigments. You can make some research about color, what type of pigments have been used to make which type of colors and things like this. Our IQ camera is very suitable for this type of application because you can really go on the field, but you can also see the underlayers because not only the visible part is in the VNIR, but there is also a little bit of NIR. And because the penetration depth is a bit longer, it's possible, for instance, to see underdrawing. About our offering, we are having at Specim several hyperspectral cameras for this specific spectral range between 400 and 1000 nanometers. First, I will focus on this camera, which is the FX10. FX10, which is dedicated for industrial application, and you can see we have actually several variants of it. The first one, which is not very variant, this is a genuine device. The one which is between 400 and 1000 nanometers, which is having a frame rate about 327 frames per second, full spectral range. Those devices, they are line scan devices and are very suitable for inline application. But as you can see, we have small variants. We have the FX10C, C standing for color measurements. And here you can see the spectral range is not anymore between 400 and 1000 nanometers, but between 400 and 770 nanometers, really focusing for color inspection. And finally, we have a third one, the FX10 Plus, which is here present when speed really matters. And here we have this one as a variant. Those cameras, they could be used online, but also offline with this accessory, which is a lab scanner. Here you can see it could be mounted that way. You have the illumination, you have the sample tray which is moving under the camera, a sample tray which is suitable to get samples as large as 40 by 20 centimeters. Be aware we also have another scanner which is a 100 by 50 scanner where you can put larger samples. Finally, there is a rotary scanner 10 which is here. Basically it is suitable when you want to go on the field. The camera is tilted and then rotating, and then you can acquire a scene outside. Another device we are having for this spectral range, between 400 and 1000 nanometers, this is our IQ here, which is compact with a touchscreen just behind. This camera is very suitable to go on the field or to go to the sample when you cannot bring the sample to you. So this camera is also between 400 and 1000 nanometers, but the scanner is included. It's still a line scan device, but the scanner is included inside. So you just put it on a tripod, you press the button, and then the magic happens. The data acquisition is done, as well as the normalization. This is done automatically. Finally, covering this spectral range, we have here our AFX, which is basically dedicated for airborne application or for UAVs, as you can see on this image. So inside this, there is an FX10, a GNSS IMU unit, a microprocessor, and then a sensor control board, which is making everything working together. This is really dedicated for UAVs installation. Precision farming is a typical application. Finally, the last products that we deliver, I mean in terms of manufacturing product, there's a spectrograph. So if you are not willing to purchase a full cased camera with full calibration and everything installed and mounted together, you have the possibility to buy the optical part only, not of the FX10. This one we don't sell it separately, but our well-known V8, V10H, and V10E, where you can put a camera just behind, and then you transform your broadband camera into a hyperspectral camera. About software, because Specim does not provide only cameras, but nowadays can provide also software. And we have actually three main software family. We have the Specim Insight, which is here for data processing. We have the Lumo family, which is more for data acquisition, including SDK. So if one wants to build everything from the scratch with the camera, we can help with the SDK. And there is also the IQ Studio, which is provided with the IQ camera. Finally, there is one of our latest products, the hyperspectral imaging platform, Specim 1. So here it is to ease and to help customers to integrate quickly and I would say in a really simplified way hyperspectral imaging into your production line. So it is composed of 3 products. So basically there is a cube, which is a processing platform. Then there is a hyperspectral camera, which is here to acquire data. And there is a software that you can see here, which is in fact Specim Insight for data analysis. The way it is used, it is as follows. So basically you have the camera, which is connected to the cube here to acquire some data. Then once you have acquired the data, you can build the model, and this model can then be loaded again into the cube. There you can process into real time, you can actually interpret the spectra acquired by the camera into classes or into quantitative variables. So basically, the output format, it is GigaVision, but we also have our UDP protocol. The good thing with GigaVision is it is compatible already with many of partners or like industrial platform which is used for that purpose. Okay, here we're going to speak about the illumination. Illumination in hyperspectral imaging is something which is actually very crucial because remember, with a hyperspectral camera, you measure the reflected light compared to the incoming one. For the VNIR spectral range, you have actually different type of options. There is the halogen, the LED, the laser, but also the sunlight. Each of them, they have their pros and their cons. And I would like to speak a little bit about them because depending on your application, you may choose one or the other ones. The first one is about halogen. The good thing with halogen is that it's rather cheap, but it provides at the same time a really high amount of light. It could be really nicely focused. So here, if you have an application where speed matters, but you do not really mind about the heat load, this is the right illumination for you. So here, typical application, it is recycling, or when you have a fast-moving conveyor belt, it could be really suitable. The next one, LEDs, it is very suitable when you need to be careful about the heat load on your sample. In some application, for example, in the food industry, where you have frozen products, you don't want to have this heat load. So here, you are really good with the LEDs. Another good thing with the LEDs is that the spectrum, especially at the blue end, is pretty high in compared with the halogen. For color inspection, LEDs is actually preferred. The laser is pretty bright. It could be used in a large range of applications when you need to have something really with a very thin line and you want to have a light which is rather intense. That's a good one. The only thing you have to be careful with is that with a laser, it is typically with a class 4, so you have to handle with care. And finally, when you go on the field, you cannot really use halogen, LEDs or laser, but you prefer to use the sunlight. But you have to be careful because between the sun, which is a light source, and your sample, there is something in between, which is the atmosphere, but there might be also some clouds. So here you have to be a little bit careful with this type of things. So here, I have to say that illumination, we could spend much longer time about it. It could be a topic on its own for a webinar because there are like many different aspects to take into account. Geometry as well. Do you want to be in a diffuse configuration? Do you want to be in a specular configuration? Depending on your application. Anyway, I hope like here, it gives you already a bit of hint what to look at. Finally, why hyperspectral imaging? This is a bit of a summary of everything. As you can see, like hyperspectral imaging is a non-invasive and non-destructive method, so you are not touching the sample. You can replace like this with automation and with this camera, with those cameras like manual work and visual work, which could be really tedious. You can also make tests in a much quicker way instead of like traditional method. You can make real-time inspection. You can cover much broader batch of your samples, like 100% of your product stream. You can improve chemical grading, looking at different things in a more accurate way at different time. You have a really high accuracy. You can also detect different parameters at the same time, and you have a large amount of application. Basically, yours can fit very easily. If you want to measure sample, if you want us to arrange a demo for you, if you want to ask for a quote, please do not hesitate to contact us. You can go to our website, or also you can see here info@specim.com. Send us an email. We'll be happy to answer to you. And remember, this webinar is part of a series of 5. This one was about VNIR. The next one is going to be about NIR, which is a spectral range between 900 and 1700 nanometers, which is going to be the 19th of October. I would like to thank you for attending this webinar. Now we are ready to go to the Q&A. So we are back. Thanks for your patience. I'm sorry, so with the video playing, it did not go as it was planned to do. So thank you for your patience and for having watched the video for most of you on YouTube. All right, so now I will start to take the question because I see we start to have quite a lot of questions. So I will take them in order. So the first question was, what is the VNIR like defined as a wavelength range? It is between 400 and 1000 nanometers. There was a second question. Some people want to find a different type of, to characterize intrinsic and extrinsic neuron particle inside USB. I have to say it's a prior question, so I don't know if I would answer that one now. So all our cameras are line scan device. So if I can answer to this question like this broadly, the customer was asking like if we have like line scan, but also like area scan device. We are making a Specim only line scan device. Having said that, we have the IQ, which is snapshot operating because the scanner is already inside. There is a question like, will there be a webinar about the application for NIR and shortwave infrared? Yes, there will be like in about a month. There will be the next session because actually this webinar is part of a family of a sequence of 5 webinars. So the next one will be about NIRs and the next one will be about shortwave infrared. So then I invite you to look at those one and I hope we will not have any issue anymore. Someone is understanding that the algorithm for identifying object can be done inside software. What if I wanted to integrate, let's say, a Raspberry Pi into it? Is there a way to communicate the data capture from the camera directly to the Linux, or perhaps at least a PLC or microcontroller? So basically, inside it is our software which is used for data processing, that you understand, and it is actually part of the Specim One platform. So it has been primarily developed for that. Having said that, you can use it offline. Then the question is like, can you get directly the data from the spectral camera into whatever platform? Yes, with the camera we have an SDK, and this SDK then allow you to make your own acquisition software and then to get the data to first set the acquisition parameter and then to get the data. So this is what you can do with the SDK. The SDK is only Windows compatible, but there are ways to have it compatible as well with Linux. So for example, if you use a camera in camera, we have a ASCII protocol, which allow you to do the same basically. And here, this is independent of the operating system. Then if you have more like a Gigi camera, you could use a Gigi compatible SDK, which is a Linux compatible SDK, which is Gigi Vision compatible. So for instance, we are using the one from Leora, eBoost. So here again, our camera, the Gigi ones are Gigi Vision compatible. So if you have such SDK, it is fine. Someone want to detect particle like metal, glass, PCs, fibers, glass PCs and fibers. So it depends on the context. The question is VNIR enough or do you need to use NIR? We'll see, it depends on the context. But the issue is like with metals, typically, the spectrum is rather flat. So you can see them, you can detect them based on the coloration. For the glass, it is quite the same as well. So we have measured metal, glasses, and fibers like with different spectral cameras. But I have to say, it depends. You want to detect those depending on what is the context. If you want to detect them from something which is organic, so typically you can detect what is then the base, and then you can detect the contaminant. So it really depends on the context. In some cases, VNIR will be enough. In some other one, NIR will be. But detecting contaminants, you always need to understand from what. Is a speaking tube able to control a motor, like motors that move the camera on the right? No. So speaking tube is here only to process the data from the camera. So you have a camera, you have it connected to the tube, and then once you have the models that you have built inside and you convert it into an app that you have then loaded into the cube, then the cube is here only to convert the spectral data into classes. So here I need to move a little bit my browser for the questions. Are there any hyperspectral camera in the VNIR sponge that can capture one shot? You need, like with the scanning method, if the subject move, it will blur. This is not convenient for me. So you need to have like a static scene. So we have the IQ for that. So basically the scanner is inside the camera. So if you have something which is static, you can do that. But we don't make a camera which can just acquire just like this. No, that we don't have. For in-field application, when scanning the plants, there are part of the leaves that are shaded. Yes, it happens. Illuminated and partially shaded. This causes difference in the spectral signature. Which is the best way to address this? Well, it's nice to have a diffuse illumination that will help. And I see that in the next part of the question, you start to speak about it. You try to have umbrella and things like this to have as diffuse as possible. This is true. Having said that, when you are dealing like with real samples, like outside, you can have issues like this, that some of the sample may be shaded or not. I have to say here, there is no proper method. Maybe you need to have like an illumination which is like a bit more diffuse, but there is no perfect way to do that, I'm afraid of. What about the lifetime of your speaking VNIR camera in harsh environment? Okay, then I would say please define what is harsh environment. So typically the FX10, also the IQ and the AFX with the FX10 inside. I would say they have been developed, especially the FX10 has been developed for industrial use. So that means that it can withstand some vibrations. So for example, the one of a sorting machine. So AFX has been developed to withstand as well vibrations that you have in a drone. So here it can do that as well. So IQ, this is a camera which is more used in a static way. But having said that, if you have a machine, you shake it or too much, no, at some point, some part inside will be unglued or then will be damaged. But if you use it according to the specs which are written in the manual, typically for the VNIR camera, the lifetime is hard to say, but it's years. There is no issue. Here we are. What is the expected lifespan of maintenance required of FX10 and FX17? It is the same. So I would say maintenance, there is only one thing you need to keep in mind. It's like if you have what we call the radiometric calibration. So radiometric calibration, basically what it does, it converts the raw data into radians. And this depends on the quantum efficiency or the sensitivity of the camera, each pixel. And over the time, this may change. So we always recommend to check the radiometric calibration once a year, maximum once every second year. But except of that, no, there is no real maintenance. What kind of data processing do you recommend, PCA or others? It depends. It depends what you want to do. And actually here I recommend you to have a look to our webinar, which was about insight. So when you want to make a PCA, for example, it is an unsupervised method. So you have an image and you want to detect if you have some contaminant or if you have like different type of features, spectrally speaking, within your sample. So PCA is suitable for that. But if you want to make more like real-time sorting, then PLSDA might be better. So you know real-time sorting is more supervised. So you need to have some training samples. You can extract the spectra and then you can teach this is the spectral signature of A, this is the one of B, and then please try to recognize it. So this is not the same approach at all. So depending on your application, you may also want to make a regression. So if you want to make fat content quantification, moisture content, things like this. So it really depends on what you want to do. I need to browse for the next one. Does the camera need recalibration over the time? Spectrally speaking, no. The spectral calibration doesn't need to be checked. The radiometric, it is what I was explaining before. This one may age over the time. Do you have a hyperspectral camera starting from around 300 nanometers or even 250 nanometers? No, that will be in the UV part. We had it like 10 years ago, but because there was no demand and the price is pretty high, so basically, no, we dropped the spectral range, so we don't have UV camera anymore. If the camera remains still, does not move on the right, etc., does the camera only measure spectra within a single horizontal line? Is there an area scan versus full pixel picture mode? No. The FX10 and the AFX10. So basically, if they are steering always at the same line, you will measure only pixel along that line. You don't have like the scanner which is included unless you have IQ camera. So with IQ camera, then you have the scanner which is included. But those are two different things. You don't have a camera which allow you to be line scan and then area scan at the same time. Does thickness of material affect the measurement by near camera? How about the color of material? So those are two things. So thickness of material, does it affect the near camera? Yes, because I will give you an example. Once I was visiting a customer and we wanted to measure different type of pigments. And those pigments, they were applied on a sheet of paper with a pattern underneath. Then we measure the sheet of paper with pigment on it with the FX17, which is between 900 and 1700 nanometers. And unfortunately, we could not measure the pigment because we were going through the pigment. We were measuring only behind the paper with a pattern. So yes, in the VNIR spectral range, you need to have samples which are not too thin because you go deeper, you penetrate a bit more. So then you will see actually what you have behind. How about the color of material? So well, then it is not VNIR, then it is a visible application. Visible application is not a surface application, and for that we have the IQ and we have also the FX10 and FX10C, as you have seen from the presentation. What kind of processing? I already answered. What about the use of supercontinuum laser for illumination? Do you have experience with that? Yes. Yes, actually, once we tested one. I'm not going to tell from whom, but we tested one supercontinuum laser, and it was between 400 and 2,350 nanometers. It provides you a rather bright illumination. It could be rather narrow. Depending on the optics you put in front of it, you can have like this a line which is more or less long. My experience is that it gives a good illumination. Having said that, you may have the same issues as with the LEDs, meaning the path line. So you have a sample which is like this, and typically you have the illumination which is at 45 degrees like this, and the camera looking straight like this. So what happens is, like, if you have a sample which is not flat, this is what we call the path line. With a supercontinuum laser, but as well with most of the LEDs, we have noticed that depending on the height of the object, then the spectrum is changing. For some application, especially which require quantitative analysis, this is a problem. When you want to make qualitative analysis, sorting A from B, then this is not such a big issue. So here it depends what you want to do. But one thing you need to be careful with laser, when you manipulate it, it could be a class 4. So here you have to be careful with maybe like putting things around. Can IQ or FX10 produce the false color IR image? Well, those cameras, they are between 400 and 1000 nanometers. So if you put your RGB band between 800, 760, and 1000 nanometers, then you can create a false IR image. Okay, so here it was about the next webinar. Next questions. What about spectral resolution in the VNIR? Is it important, useful to have very good resolution compared to sphere? What can we expect in terms of spectral information? Again, it depends on the application. If you want to look at color, I would say that a good and sufficient spectral resolution is about 5 nanometers. That's fine. Having said that, if you want to start to look at some really accurate peaks, some of the plastics, they have some between 800 and 900 nanometers. Those peaks, they are really narrow. So here you may want to have a better spectral resolution. That's sufficient. For some application, for like moisture, sugar, and oil detection, where you have the peak at 930, 985, and 970 nanometers. So then the peak is rather wide. So here you don't need to have a high spectral resolution. You can have, for example, like 10, 15 nanometers. So the spectral resolution, it really depends on your application. And it is the same, for example, when the NIR, because we were also asking about NIR, it depends what you want to do. If you want to sort two plastics and the peaks, they are really close from each other, well, then you need to have a really good resolution. If you still have two plastics, but with peaks which are really far away from each other, you don't need to have a high spectral resolution. So it's a little bit application specific. Is VNIR safe to be used over human skin? Yes. For example, if you're analyzing a sample that is over skin, yes, because here you could use illumination source which are not providing heat. So for example, you could use LEDs. LEDs doesn't burn the skin at all. And then between 400 and 1000 nanometers, you start to have good ones. So FX10 or like will not make any harm. I have to say this is not the camera which is a problem. Very often it is more like the illumination. But then here you can use an illumination source which is not providing any heat. So LED could be an option. I'm doing research for Sea Potato, a breeding company in the Netherlands, and we are looking for a camera that can measure starch and distribution through a tuber. Yeah, okay, but it's not a VNIR application. Starch, it's more like an IR application, even a sphere application, but it's nothing to do with VNIR. But we have actually some camera which are used for this purpose to quantify the starch like this in different type of samples. How does the FX series collect data at the height of 3 meters? The FX camera could be used at whatever distance. It's just like we have different optics available. So we have like from 12 degrees, I think about the FX10, for example, from 12 degrees up to something like 80, 85 degrees. So then if you have a wider field of view, it means that the line is getting wider and each pixel is getting bigger. So if you put the camera at 3 meters away from the sample, this is not a problem. It's just that the pixels are getting bigger. So no question about it. It's the same for the FX17 and for the FX50. Can we identify material based on their spectral signature and some store library to compare in IQ? Yes. So basically, you can build your spectral library with spectra acquired from the IQ, and then based on that, you can then compare. You can then take the spectral library you have generated from somewhere, so you have both, and then you can apply this one to data acquired on the IQ. I have to say, with Insight, you don't have the possibility yet to import spectral library, but I know this is something we're working on. I hope I answered the question. Can the speaking cube be integrated into a PLC? How fast the data being processed with speaking cube? Yes, actually, the idea of the cube is to be used in machinery for industrial use, like when you have a conveyor belt, and then you can have some actions, like for example, nozzles which are ejecting things like this. So basically, the output of the cube could be the input of a PLC-based system. So for example, the system from Alcon, but also from Beckhoff and so on. There are some other ones. So the output of the cube is GigaVision compatible. So as soon as your PLC is able to get as an input a GigaVision signal, then there is a match. Also, for the cube, we have our own UDP protocol. So here you can make some coding as well. And about the speed, it's a bit hard to just give a general answer like this because the processing time in the cube depends on the model, it depends on how many classes you want to detect, it depends on the pre-processing as well that you have implemented in your model. But typically we are talking about a few milliseconds. So yes, we have customer using actually the cube and it's able to run at a few millimeters per second. but the belt is at few meters per second. I have the next questions. Can you explain more about material and penetration? Plastic, glass, paper, metal. So basically, the longer you go for like the wavelengths, the more you can see inside the material. But it depends on the material as well. You have some materials which do not have any penetration depth, so it means that even the camera cannot see through at all. But you have some other one where you can. So if I think, for example, about medicine pills, you know, sometimes it can be inside a coating, so you can see through the coating in the NIR, but you cannot see through, for example, if it would be a coating with some aluminum or something like this. So it depends on what you have as a sample, but it is true, the longer you go for the wavelength, the more is the penetration depth. Does Specim have application example on disease and pest detection of chili plant? This particular plant, no, as far as I know, we don't have example. Having said that, we know that our cameras could be used for precision farming and precision agriculture. 3 meters, we already have it. What is optimal measuring distance for IQ? Depends what you want to do. I can just say that the minimum measurement distance is 15 centimeters. VNIR versus tunable diode laser absorption spectroscopy for detecting oxygen. Okay. There is no real question like what is VNIR compared to those ones. It is different. So tunable diode is more like tunable diode laser. It's a different type of topic, so I will not go too deep here. What is the best way to determine which spectral range should be used in studying a sample? Well, to make a test. There is no other way, so you can check the literature, you can make some tests. Why the spectrum from an FX17 halogen lighten always have a negative slope at about 350 and 1000? This is because you have within the material, within the glass, which is inside the FX17, you have some OH band, and those ones absorb a little bit, about 1400 nanometers. So this is what you see when you put an halogen and when you look at the white reference. What are the most commonly used software for processing VNIR combined with LiDAR? Well, we know that, okay, this type of application is more for remote sensing. So NV is actually a pretty good software for this type of application. So I don't know how much it can do the data combination between LiDAR and also VNIR. But otherwise, MATLAB could be another one, maybe Python. Speaking camera software can info positioning sample or not for do. So here we cannot do with insight, we cannot do the positioning. Having said that, if you are thinking about like remote sensing application, we have what we call CaliGeo Pro, which allow you to do some georeferencing. So here you have the possibility to map the pixels. Can Specim Insight create a model based on a few discrete bands and frequencies? Yes, you can actually. With the FX camera, you can choose not to look at the full spectral range, but to select only those. And then you can build the model based on those only. So here you have the possibility to do that. Do you have a good source of non-spectral absorption reflection spectrum for various chemicals? No, it's only, I would say, based on experience. You can find some charts also on internet which relate different type of band with the spectral range. But no, we don't have such a spectral library. Well, having said that, we have application specialists like I, and based on our experience, we know already where to look for different type of chemical. Is there any more question? Maybe we have the time to take like one or two more. Yes, there is one. Is there any significant difference between R7S halogen and 3000K and the one provided by Specim? So I have to say, I don't know what is an R7S halogen. Oh, you mean like a general one, maybe at 3000 and 3200. Well, basically, this is the emission, which is a little bit different. So when you are 3200 Kelvin, you have an illumination which is more tilted towards the blue. But what is the difference? I mean, it depends again from your application. If you have an application which requires to have more blue light, so for example, for color measurements, you need to have like something which is a little bit warmer. So it depends on your application. But if you think about FX17, then it doesn't really matter. Can you select an hour wavelength range for the full range? As we have already had a look. Can FX10 be used outside for precision farming, or does it need to be in a... No, FX10 can be used outside. You don't need to be in a controlled environment. There is no issue with that, especially with the radiometric calibration. You can use it like this outside. How to make the halogen lamp suitable for both VNIR and ZR? Halogen, this is what we use. So, for example, on our lab scanner, 40 by 20, but also the 100 by 50, we are using halogen, and those cover the full spectral range between 400 and 2500 nanometers. Okay. Do you sell wide body calibration object? Yes, this is part of our lab scanner. We have some reference style, white reference style. So we have those. Yeah, we have gray ones as well. What do you have in mind for measuring mature corn canopy with FX10? What do I have in mind? I would say I would use AFX, maybe AFX10 if you want to use it on a drone, or then you could use, like for instance, the FX10 on a cherry picker. You can use the sunlight with radiance conversion again with a radiometric calibration. This is what I would have in mind. Can I open use hyperspectral image file gained by speaking like you with other software? Yes. The acquisition format of our camera is not proprietary. So basically it is an NV format, and we have many of our customers using Python, MATLAB, or whatever the software. Is it possible to apply the spectrograph only on an ordinary microscope? So the spectrograph only, you mean like the V10E or the V10, for example? Yes, you can, if it has a C mount, but then you need to put a camera behind to be able to acquire something. Also, with a microscope, you need to think about the illumination. Typically, the LEDs which are included, they are not really suitable for hyperspectral imaging. And also, you need to have a scanner. How much of this analysis is done in real time? I have to say it depends on the application. For some application, you want to do it online. So, for example, when you want to have food and you want to detect some contaminant or things like this, so then this is done online. And here, you can use our platform like Specim 1. But then you can do some offline as well. So for example, what was like you saw from the presentation, like art inspection. This doesn't have to be done online. You can first acquire the data and then look at them in your lab. So it depends on your application, but you have the possibility to do both. If I need a sphere camera, how much does it cost? So here, basically, I recommend you to send an email to info@specim.com, and here our sales team will contact you. What are the best wavelength band for PCB scanning, especially looking at oxide layer and detecting changes, tampering? Well, first of all, you have to think about the spatial resolution you want to obtain. So, because typically when you want to look at printed circuit board, you may need to have a high spatial resolution. So first you need to define, like this, which pixel size you require. But then, having said that, after that, based on our experience, the VNIR spectral range is actually pretty good to detect some oxides from the genuine or non-oxide metals. So I would say VNIR, that's the proper one. But again, you need to think about the spatial resolution. What is the software you use for the true color colorimetry analysis? It was Insight. So here you were able to see, like with our Insight software, you can select some spectra a bit everywhere and then to convert those into color coordinate. And yes, this is compatible with our Phoenix camera, which is our camera between 400 and 2500 nanometers. But so having said that, if you want to make colorimetry, I do not recommend to use a Phoenix, but I would rather use an FX10 or an FX10C. I think this is more like suitable. Are these cameras programmable in MATLAB or Java? Basically, all our cameras, except of the IQ, have an SDK. So with the SDK, you have the possibility to develop your own acquisition software. And some of our customers are using MATLAB without any problem. By the way, in our production, actually, we are using MATLAB like to make the spectral calibration and everything. So that's not a problem. So MATLAB is one way to do via our SDK. Java, I haven't heard, but I will not see why it will not work. What is the approximate cost of FX10? Well, again, it's the same question somehow with the Sphere camera, so I will ask you to contact our sales team. Is it flame-proof? To some extent, so I would say don't put it to any fire. So if you want to measure some really hot bodies or like really hot emittive source, it might make sense to protect it as well with a casing. Is the AFX line scan 2? Yes. This is a camera we have designed for airborne application for UAVs, and it is also line scan. So basically you need to define a flight line with like the flight management system, and then from there then you can acquire some data. Notice that we have a flight management system as well, so you can trigger and stop, like start and stop automatically the record of the frame. How thin of film thickness can you measure with VNIR Hyperspectral system? So to measure thin film, you have actually two approaches to measure the thickness. Either with transmission, so you imagine you have a certain film with a certain material with some absorption peak. The thinner it is, the more the absorption peak will be pronounced. So that's one way to do. So here I don't really have a number. But then for the one we were showing in the PowerPoint, it was basically based on interferences. So you imagine you have the thin film like this, the light source here, and you were looking in a specular fashion. And then depending on the film thickness, you can have interferences with shorter or longer pattern, I have to say, between the interferences. And here, with the FX10, we recommend the thickness is between 1.5 and about 30 micrometers. You can use also the FX17 to do that, but for thicker film. Where the data is stored in the cloud. So basically here you can choose to store your data wherever you want, but first you typically acquire them locally. So you have the camera connected to the computer, to the cube, and then you acquire the data locally, and then you can then transfer them to the cloud. I need to move a little bit here to see more questions. Sorry for that. Okay, so how can I turn a normal camera into a spectral camera? So if you mean by normal camera, a RGB camera, I would not say that's really possible. But what you can use a broadband camera, for example, sensitive between 400 and 1000 nanometers, and then in front of it you can put a spectrograph. So then you will transform your broadband camera into a hyperspectral camera. Does the Specim camera for drones have image stabilization? What is the battery demand for such a system? So the camera itself doesn't have a stabilization, but you can put it on a gimbal. So many drones, they have the gimbal as an option, and then you can mount the camera on it for stabilization. For the battery demand for such a system, I do not remember just by heart like this the consumption. I could imagine it's between 5 and 10 watts. I have to say here, maybe you want to check the data sheet on our website. I don't remember just by heart like this what is the power consumption. Isn't the huge size of hyperspectral dataset a problem in transmission, storage, and processing, or is it mitigated? So basically, this is true. Like if you want to transmit data from one place to another place, you may need to have like a good bandwidth. But in terms of processing, with the current GPU, the current computing unit, you have the possibility to just get each line, and then each pixel can then be converted into classes somehow. They can be processed in real time, and this is what we do with the cube. So we have the possibility with the cube to acquire data at frame rate up to 2000 frames per second, and each of them, they are processed in real time. So here, with new processing unit, you have the possibility to do that. I'm a PhD student and I need extra support from you. Okay, so it's not really a question, but if you have any question, please drop us an email. Does the Specim cube come with the price of the camera, or is that an extra? This is separated. Here you need to ask our sales team how to quote it. typically the cube is a separate accessory from the camera. What is the effect of artificial UV bulbs as a light source? What do you mean by artificial UV bulbs? I'm not sure to follow here. What do you mean by artificial UV bulbs? What I can say is that the light source you need to use for hyperspectral imaging basically is a continuous spectrum over the full spectral range. It doesn't matter if it is like LED, halogen, supercontinuum laser or whatever. The most important is that you are having a full spectrum over the full spectral range. Interested for art, painting application, which instrument is suitable? LED illumination, what spectral resolution, what accuracy? Can I save data as TXT? Okay, it's a lot of questions at once, so let's take them in order. Which instrument is suitable? It depends what you want to do. If you want to inspect pigment just to see colors, then I would say the VNIR spectral range is suitable. Already with VNIR you can see a little bit the underlayer, but if you want to see more the underlayer, then you may want to go for the longer wavelength, which is like FX17 or even the SVIR camera. With those cameras, actually, with FX17 and SVIR camera, you can also detect and monitor different types of material which have been used to make the pigment, or like to make, for example, a piece of art like a tapestry, for example, if it's made of cotton or if it's made of silk or whatever. For the illumination, if you are afraid of the heat, then you may indeed consider the LED. LEDs, you have some between 400 and 1000 nanometers, and you can find some others as well between 900,000 nanometers and 1650, 1700 nanometers. You can use those, but again, you have to consider that you don't find an overall one between 400 and 1700 nanometers. In terms of spectral resolution, if you want to speak and to see about colors analysis, you need to have a spectral resolution which is below 5 nanometers, of about 5 nanometers. This is what we have with the FX10, and here this is suitable. Then for the longer wavelengths, if you want to see the underlayer, if you want to detect different type of material, 12, 10, that's enough. Can you save the data as a TXT? So basically the spectra can be saved. So for each pixel you can extract the spectra, and the spectra can then be saved as CSV or TXT, but the data itself cannot. How much does it cost? Again, please send an email to info@specim.com. How about database in pigment in cultural heritage painting? So here, typically, you will need to build your own database. So you may have a palette with some reference samples, reference pigments. You measure them with our camera, and then based on that, you can make your spectral library. Then, once you have your spectral library, you can use it in different software to make classification and things like this. I will move to the next ones. Is there any plan to visit any event like fair, etc. in near time, especially in Asia? We have actually an office, as you have seen, in China. So Asia is pretty big. So it depends which country you are talking about, but we are going to trade fair in Asia. We have our Chinese team, they have been in China. We have also some of our distributors going to different countries. Myself, in the near future, I'm not just planning to go to Asia, but we have some events. So again, here, send an email to info@specim.com, then we will tell you. Next webinar goes into longer wavelengths. Yes, as do your equipment. Any plan to work toward UV in the future? No. Actually, we had UV hyperspectral camera in the past, about 10 years ago, but because of a lack of the demand, we decided to stop it. And by the way, using UV hyperspectral camera is not so easy because you need to think about the light source, and UV light source can be dangerous for the user. So no, we are not planning to go there. What are the physical unit output by your VNIR sensor? Digital number. This is what you get primarily as the raw data. But then you can convert those data into reflectance, which is then a %. But if you have the radiometric calibration, you can then convert the raw data into radians. Do you offer algorithm in your image analysis software to correct to surface reflectance? It's exactly that. So basically you need to acquire the white reference, the dark reference, then you make the ratio, and then you can obtain like this the reflectance data. Okay, so that's a comment from Specim. Does Specim offer non-line scan, non-scanning cameras? No. All our cameras are line scan device. We have only the IQ, which is like snapshot operated because it has a scanner inside, but all our cameras are line scan device. Since there are several types of camera, how do you help your customer to choose? Well, first you need to think about the wavelengths. So if you think about the wavelengths, our customers, they typically come to us and they ask, okay, we have such application, such a problem. Can you help here? So what we do, we can make a feasibility study, we can make some sample measurement, and then we can estimate for your problem which wavelength is the best one, the one solving your issue. So that we can do. Sometimes we just know by ourselves, based on our experience, which camera you need for which application. If that's the first type, so it is to select actually here the spectral range. Then for the camera, it depends on the requirements, the accuracy, the stability, if it is online, if it is offline, if it is in the field, if it is in the lab. Well, we have an application team which is here to help you to choose the right device. Is it helpful to combine light source or better to just use one? No, you can combine as well. For instance, we have customers working in greenhouses or working in the lab, for example, who want to work to make color measurements. They use halogen, but you know with halogen you are pretty poor in the blue end of the spectrum, so then they dop them with some LEDs which are richer in the blue emission. So you can combine illumination together. The most important is that you try to have something stable over the time and also spatially. I go to the next questions. Can it be used to characterize the shape, size, density of cutting inside non-Newtonian fluid which is thick? I don't know. I have to say I don't know. So the best is that I prefer to say I don't know than to say yes or no. So it's better to contact us and then we can try to find more into details if it works or not. For core logging application, which instrument is suitable if I want to detect minerals? It depends on your minerals. As a rule of thumb, for core logging, the sphere camera between 1000 and 2500 nanometers is the one providing you the most information for many minerals. But for some of them, it might be good to combine with the VNIR spectral range with an FX10, or to combine with an FX for longer wavelengths, for example 50, or then the long wave infrared. So when you combine those spectral range together, then you can identify more and more minerals. It depends which one you want to look at, feldspar, steel related, things like this. So here it really depends on that. You can notice as well that you can use a high RGB camera to get the texture as well. So be aware that in our portfolio we have what we call the CISO rack, and with the CISO rack you have the possibility to put up to 3 cameras next to each other at different wavelengths, and with this data fusion then you can make more accurate core logging. Which camera would be best for determining protein and fat from a given samples? FX17. You are more into the NIR spectral range. Fat and protein, they have more spectral feature like this in the NIR and also the shortwave infrared. So if you think about best, it will be shortwave infrared. FX10, FX17 between 900 and 1700 can do it as well. It seems that we don't have, yes, we have one. How do you calibrate your camera radiometrically? That's a good question. So basically, what we do, we take our camera, we put it in front of the opening of an integration sphere, and inside the integration sphere, we know perfectly well what is the light and also what is the reflection within inside the sphere. So then we put the camera in front of it, we fill the field of view, and then we obtain some raw data, and based on that, then you can get a corrective matrix. So this is the way we do the radiometric calibration. You mentioned the Phoenix isn't preferred for colorimetry. Can you describe why more in depth? It's what we currently have, so seeing if we can use it for that application. Okay, so if you have one already, then you know how to use it. So if you know how to use it, then you know that if you want to use it in the laboratory use, you cannot get closer from about, I think it's 90 centimeters or 1 meter, if I recall well. And then you have a pixel size which is about 1.5 or 1.6 millimeter as the smallest pixel with a Phoenix. So when you do that, you cannot get really like, how can I say, very small and accurate distribution of color. But if you have like large sample which are, and you want to check the homogeneity, then it is fine. So here, that was the reason I was saying that, because it's another kill, because you know Phoenix is between 400 and 2500 nanometers. For color, you need only the spectral range between 400 and 760 nanometers. So that's why I was saying it is not the preferred device. But since you have it, you can indeed extract the visible part of the spectra from the general spectra you are getting, and then you can just get the colorimetry. What about detecting disease on agricultural crops? Do you have application to support analysis of airborne data? The detection of disease, this is true, can be done with AFX10. So this is airborne, like dedicated camera. And this is the one between 400 and 1000 nanometers. And this is true that you can use it to detect different type of pests, or if you have different type of stress on plants. We do not provide application as such for such, how can I say, such a tool for such application. But inside, actually, the software inside, you have the possibility to make band ratio, for example, NDVI or some other one. So here you can actually code and put yourself your own index, and then you can get like this different type of mapping like this. So we don't have really libraries, spectral libraries, or special application like, application for this type of application, but you can make them yourself within the inside software. I need a HSI camera for the polymer identification, but often comes the problem of black ones. Can the VNIR HSI camera help, or should I go to the MVR ones, MWIR ones? That's the correct one. For black plastic, you need to go with FX50. This one allows you to sort different type of plastics, and regardless if they are black or not, you need to go with that one. How much time take to get data from a picture? What is depending on? If you think about the IQ, it depends on the light that you have in your area. So typically with IQ, it may take between few seconds, let's say 10, up to 3 minutes. So if you have good light condition, it's much faster. If you think about the FX10, for instance, on a lab scanner, it depends how long is your scan, the quantity of light that you're having as well. So if you think FX10 with our lab scanner, typically it takes about 20 seconds. Any event near Caucasian region, maybe Turkey?
And reply.
So here we have actually the moderator who is going to answer that one. All right, so if there are no more questions, so I think we can conclude. So yes, so I would like to thank you for taking part to watch us like this, to be part in this webinar. Be aware that in about a month we will have the next one, which is this time about the VNIR spectral range between 900 and 1700 nanometers. So please join that one as well. We will be happy to have you, to host you. I wish you to have a nice day, a nice evening, and again, thanks for attending. Bye-bye.